Hi, everyone. Thank you for joining us for our next episode of our Spotlight on GitHub Advanced Security series, Navigating the Depths of API Security Testing with 42Crunch and Microsoft. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on the chat. We'll be dropping links and checking for questions for our presenters to answer. Our session is recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Thanks so much for joining us today.
Thanks, Anna. Hi, everyone, and thank you all for joining today. My name is Horace. I'm one of the product managers working on Microsoft Defender for Cloud, and I'm joined here by Hisham. Hisham, did you want to give a quick intro as well?
Hey, everybody. Thanks for having me. Happy to be here. My name is Hisham Attar, a solutions engineer here at 42Crunch, focused on API security.
Awesome. Thanks for that intro. And with that, we'll pull up the slides here that we have. So for today's agenda, we'll be walking through kind of navigating the depths of API security testing. So if we go to the next slide here, we'll walk through the agenda that we have for today. Hisham, could you go to the next slide there?
There you go.
Great. And then here we have the agenda for today. So we'll start off with just basically walking through why is API security important. So we'll be walking through just an intro to the area, why it's really picked up, what's unique about API security. We'll also walk through some real world examples of breaches that have happened over the course of the past couple of years. We'll look at some look close at some of the top risks when it comes to API security as well, such as broken authorization. And then we'll wrap up talking a little bit more about the solution for how you can actually build an approach for API security within your organization as well. And then we'd love to leave some room at the end for any questions from anyone as well. So with that, we can go ahead and get started with the first topic. So again, why is API security important? And with this, we basically breaking it down into three kind of distinct pillars that you're seeing here. The first one is that APIs are ubiquitous nowadays. So whether you're buying groceries on your mobile applications or you're searching up weather on your search engine, chances are APIs are what's powering those various digital experiences. And you can see here that 83% of internet traffic is now driven by APIs. And in the next couple of slides, we'll actually walk through in more detail what's really the difference between API traffic versus more generic kind of web traffic that we've seen in the past. The second pillar that you're seeing here is that traditional API security measures are inadequate. So, for example, your organization might already be using something like a web application firewall or an API management service. And although those services are great and do provide some level of security, they're not comprehensive in the case that they will cover any behavioral kind of threats when it comes to API security. And that's where a lot of the risk stands today. And then the last piece that we have here is that APIs are really the most frequent attack vector as well. And we'll actually go to the next slide here that will talk a little bit more about this part in more detail. So what you're seeing here on the screen is just a small subset of the number of API-related attacks that we've come across over the course of the past couple of years. And what I'll mention as well is, especially over the course of the past year, the number of these API attacks has really skyrocketed as well. So just within the slide, you're seeing just the impact that these API-related breaches can have on organizations. So in this case, you can see fines and revenue impact in the millions here. This can lead to PR damage, as well as service disruption and account takeovers as well. So really, an API risk can be quite monumental for any organization of any size in this case. So there was kind of a brief background and kind of the importance of API security. Next, we'll actually walk through a bit more detail here on the next slide. We'll go through a little bit more about what makes API security a bit more unique compared to web security. So here what you're seeing on the screen is kind of an analogy in this case of more traditional web architectures. So in this case, this might be more of a monolithic style application architecture where you might have maybe one or very few servers within your organization. So when it came to the core security elements, like handling authentication, handling authorization, where is my data going? What type of data is flowing? You had a really clear defined path of what data was leaving within and going in within your servers in this case. So you can see we have kind of this fortress and set walls. You can see all the traffic going in and out of this environment in this case. So that was a world with more monolithic style architectures in this case. But now if we go to the next slide, now we can see a bit more detail of what this looks like for APIs in this case. So in this case, APIs kind of bring this proliferation of more microservice-based architecture. So in this case, now we don't have this scenario of a few requests going to one or very few servers. Rather, we have this scenario of tens and hundreds of requests going to tens and hundreds of different microservices, which are communicating with other microservices. And this really expedites this problem of, hey, where is my data going? What type of data is flowing? How am I handling authentication? How am I handling authorization? And that's really where the problem of API security starts. And then here on the next slide, just so you have a bit more detail on this as well. So after this presentation, for example, if you're interested in learning anything more about API security, there is a nonprofit research organization called the OWASP organization. They're very popular for coming out with top 10 lists for various aspects of web and application security. They have a specific list for API security risks. So they originally released it in 2019. They've updated it here in 2023. And this really outlines the unique and specific risks that come for APIs as opposed to generic kind of web traffic as well. So if you are interested, this is a great kind of reference link to learn more after this presentation as well. And each of these risks that they've outlined here, they have a lot of examples on specifically what the exploit could be and then how to prevent it as well. So kind of what the developers need to think through as they're building applications to prevent these types of risks from entering the application. So with that, now we'll go into a few actual real-world API breach examples, just so we can go into more depth and actually see how easy it can be to accidentally introduce an API-related breach within an organization. So here's the first example. This is for a global shipping company. In this case, this was found by security researchers. They were able to discover that they could call a series of API calls to retrieve personal data for customers that are using the shipping company. So the way that this worked is first they had to call an unauthenticated API endpoint. What that means is basically anybody has access to this. There is no access token. There's no bearer token. There's no user login or password to access the API endpoint. It's publicly accessible in this case. So they're able to call this API endpoint. And in the request, they need to pass in a parcel ID number. And then in the response, you'll get a map back of the location. So that's kind of what you're seeing here on the screen. You can see kind of a map coming back in that response. What's interesting here is that parcel ID that's being passed in is an all numerical ID. It's less than 10 digits and fairly easy to enumerate. So you can write a script to go through all the different possibilities for those parcel ID numbers in this case. So again, what this API does is in response, it comes back with a map response that you're seeing here. And what security researchers were able to do is they're able to actually use this map and use the street names that you're seeing here to basically derive what the postal code for the same location would be as well. And then if we go to the next slide, we'll actually see that there's a second unauthenticated API endpoint, which now takes both the parcel ID number and the postal code in this case. And now that we have both of those pieces of information, you pass it to this API and it will return full details on that shipment. So that includes the customer's full name, email addresses, phone numbers, and other PII data in this case as well. So if we go to the next slide, we'll actually see kind of what went wrong here, what the impact was, and some of the lessons learned in this case. So luckily, this was found by security researchers, so it was responsibly disclosed. And they were able to, the company was actually able to fix this before any kind of exploitation occurred. In this case, so this company handles more than 2.1 billion parcels annually. So you can see that if this did fall in the wrong hands, the breadth of impact that this could have had on an organization. Some of the causes in this case as well. So in this case, one of the main ones here is you need to return the minimum information necessary when it comes to request and response bodies, in this case for APIs. And the second one is you need to implement proper authorization and authentication controls, especially when dealing with sensitive PII data. So in this case, you can see that both of those were unauthenticated API endpoints. And really the authorization in this case was not really based on a user ID. Rather, it was kind of that pair of postal code and parcel ID number. That was kind of the authorization in this case, which in this case could be easily guessable by attackers in this case. The last part of this is you also need to enforce rate limits. So what was also unique about this case is that the security researchers were able to enumerate all the different types of partial ID numbers in this case without any blockage, without saying, hey, you've called this API too many times, we're not going to let you do any more calls. So that's basically what a rate limit is. And in this case, there was no rate limit enforcement. And essentially what rate limits do is they can basically halt the breadth of impact in this case, right? So that was kind of the main causes and lessons learned for this particular case. We'll walk through one more example of a breach here. The second one is for a smart scale application. So essentially what this is you have a mobile application that's connected to an actual weight scale in this case, and it also is used for tracking other health data that you might have for you or your family members as well that's connected to this application. And in this case, what researchers found is multiple exploits that can lead to both returning sensitive data as well as a full account takeover for this application as well. So we'll walk through both of those examples here. So here in the next slide, we'll actually walk through how this process actually looks like. So when you start this application for the very first time, you're prompted to register for an account. And the way that the registration works is you call /register API in this case in the backend. And what you'll be returned is a unique 9-digit user ID. So it's kind of hard to see here, but on the left-hand side, you're seeing that request for a register. And then in the response, you're seeing that the response body actually contains that 9-digit user ID in this case. So if we go next here, you'll see that 9-digit user ID was actually found to have a common pattern. So in this case, the first 4 digits of that 9-digit user ID seem to be repeating. So when security researchers were trying this out, they created multiple accounts. They saw that the first 4 numbers always repeated, and then the last 5 or so numbers were unique in this case. So in this case, what they did is they would enumerate through all of the possible combinations for the last 5 digits in this case. What's interesting about this particular security scenario, though, is that this is an authenticated API endpoint. So this is no longer a publicly accessible, unauthenticated API endpoint. In this case, in order to call this API, you need to have an access token. But the authorization was misconfigured. So what that basically means is I'm an authenticated user, but I'm able to access somebody else's data in this case. So we have broken authorization in this case. So in this case, their security researchers were able to enumerate through all the possible user ID values, and they're able to return back sensitive information for all of these users in this case. And that's what you're seeing here. On the right-hand side, they're enumerating through all the different possible digits in this case. And here we just showcased just the first name that's being returned, but this also included other details such as birth dates, profile pictures, and some other PII data as well. So that was one of the vulnerabilities found for this smart scale application. There's one more as well that we'll showcase here on the next slide. And that was basically that the reset password API endpoint did not have any rate limiting enforced. So we've probably all seen this prompt before where you need to reset your password and then it sends you some kind of code back to your email or maybe through text message. In this case, what this application did is it would send a 6-digit reset code back to the user's email. The problem here is that 6-digit code doesn't enforce any rate limiting for actually validating the right code in this case. So what security researchers were able to do is they were able to try every single possible 6-digit code that existed, and eventually they were able to, of course, brute force their way in until they got access. And once they got access, they were able to reset the password for that account, and now they successfully performed a full account takeover. So they could log in, view all of the health details, as well as even delete accounts if they would like to as well. So next, we'll walk through some of the lessons learned in this case. Again, the potential impact could have been extended to over the 500,000 users of this application, but luckily this was disclosed to the team early on. Another part here is that although these vulnerabilities were actually disclosed, it actually took 7 months to actually be remediated after disclosure. And this is a really common case, right? Especially when some of these vulnerabilities are really embedded into the logic of the application. It can take a while to actually roll back and revert and actually patch these types of security flaws. So that's a big issue in this case, as well as once flaws actually make their way into production, it's very difficult to change. The ideal case would be to catch this much earlier on. And we'll talk a little bit more about that here in some of the later slides. But some of the other lessons learned here, we talked about this, is that broken object level authorization. So in this case, we had an authenticated API endpoint. However, the authorization was misconfigured in this case, so somebody was able to access somebody else's data. Some of the lessons learned here is that we need to enforce authorization checks at every single step. You should only be able to access the data that you're supposed to have access to and nobody else's data. To use GUIDs and UUIDs for user IDs rather than numerical IDs like 9-digit numbers, you should use a more random sequence of numbers and alphanumeric characters in this case as well, enforcing rate limits just like the last case as well. And then the other key aspect is to return the minimum information possible as well when it comes to response bodies. Great, so that was a second example there. And then for that broken object level authorization, this is one case that I want to talk a little bit more about. As we mentioned, it's actually the number one risk outlined by the OWASP organization as well. It's one of the most common flaws when it comes to API security. And so now I'll walk through kind of an example of how easy it can be to actually incorporate this into your application. So in this case, you're seeing here on the right-hand side, just a sample application for ordering and editing shipments in this case. And this particular application does have a flaw in it in this case, where you're not actually enforcing authorization in this case. So I'll give a second for anyone to kind of go through and look through this and see if you're able to actually spot the issue in this case, and then I'll walk through what the issue is here. Great. So hopefully some of you were able to actually go in and see what the issue might have been in this case. So here you're seeing, as we mentioned, you have this class for order manager, and then you have all these functions written underneath this particular class. And you can see that we have functions for get order, edit order, and create order as well. So you can see in this case, if you click next on the slide here, you'll see that in the edit order function in this case, we don't have any authorization check. So if you look at the get order right above this function, you can see that we have this if-else statement that if the order.userid is equal to the actual user ID of the caller, then we'll return the order. Otherwise, we'll return none. In this case, it's an unauthorized user. So we've done that for getting the order. However, for editing orders, we forgot to basically implement that same authorization check. So now you might be able to edit somebody else's order. In this case, it's not belonging to your user ID. So that's really just an example of how easy it can be to really embed kind of a broken authorization check into your code here. So there is kind of that example. And then with that, I want to actually pass it along to Hisham now, who will actually walk through a bit more details on how we can actually build a comprehensive API security strategy. And he'll also walk through a demo of 42Crunch as well. So with that, Hisham, would you like to take over there?
Awesome. Thanks, Hars. Yeah, so we'll flip over here. Again, everybody, my name is Hisham Attar from 42Crunch. We basically focus on ensuring APIs don't reach production before being secured and tested. So that's really our whole philosophy. And so really, what's the issue here, right? Development, they play hard to catch. So what do we mean by that? Well, today developers, they're extremely talented, right? They move quick, they code and deploy fast, and they're in big numbers, right? So when you think compared to your application security teams, right, they're doing their best to keep pace, but they're typically outnumbered. So as a result, it becomes difficult to secure, growing APIs, fast-paced deployments. What we found really is that the way you can sort of keep up is if you bring automation into that equation. So automation is key here. By having a structured process in place to automate API security into your developer pipelines, as you might do today with some other tooling, you can really begin to build that process and gain automation. So the foundation of this is OpenAPI or Swagger. So I'll just ask this question. If anybody has heard of OpenAPI or Swagger, feel free to drop it in the chat. Basically, OpenAPI is a language agnostic standard for describing and documenting REST APIs. And it's used pretty widely across many organizations. And really what it does is it gives us both a human and machine readable way to understand how the API operates, how it works. We can understand all the data of that API, and we can create automation around it. So, beyond just documentation, if you think of Swagger, OpenAPI as just documenting your APIs, if you leverage that documentation appropriately, you can do so much more. You could do code generation, refactoring legacy apps into microservices, better developer enablement, integrations, for your APIs. If you want developers using your APIs, right, better enable it for them, and then even security testing. So which I'll show you kind of here in the next slide. So, what you're typically seeing here, this is like your typical software development lifecycle, right? So you might have various stages in here like design, coding, and testing. So you design your API first, right? Do some coding and testing locally. And usually developers are doing that stuff. And then they'll commit that, push that up to source control, right? And then in source control, you might have some automation or in your delivery pipelines that kicks off some additional functional testing, QA integration types of testing. And so all this is tied with the software development lifecycle. So the idea here is by introducing API security in at design time, if you notice, there's a little contract scoring here. This really allows you to start to leverage automation of API security testing. It's centered around this idea of a contract. So you see contract scoring, contract testing. Really, the contract starts out as the OpenAPI spec itself for the Swagger document. And then it really evolves or becomes this secure definition of your API. So the way this works is, where you see coding and testing, we do contract testing and contract scoring. Basically, we can run static analysis on the API definition to ensure it doesn't have any data or security flaws, and then provide remediation and best practices on those issues. And then take the same approach and take that Swagger now and use the Swagger, which we've analyzed statically, and we've found if there's any vulnerabilities and analyze. We'll then analyze the actual API implementation. So we do dynamic testing of that API against that Swagger contract without needing the source code. So the result is you get very targeted API security testing on that API with the context of the API in mind, because we're using the Swagger as the guiding piece. If you think of the contract or the Swagger, it's going to contain all the good data for that API and what should be allowed and what should be responded with, right? So this is the guiding piece. This is the template for all the security tests. And basically it's going to enforce, for developers, they can run those static and dynamic checks that I'm talking about here locally in their IDE. So they have the tools in their developer environment, like let's say VS Code, IntelliJ, or Eclipse, your favorite IDE. We have the same tools so you can do that contract scoring and testing. And then security teams get those same tools and extensions so they can enforce those static checks and dynamic checks. And any standards and policies around their APIs, like they can say, no API keys are allowed for this set of APIs, or no basic auth, right? So you can start to enforce those policies around your APIs. And everything is centrally managed through the software development lifecycle. So you're touching that API from code, test, deployment, all the way through, effectively introducing API security every step of the way of that software development lifecycle. So that was a quick overview, right, of where does 42Crunch kind of fit in? How can we test API security starting from the design? So what we want to do now is show you all a demo here of another sample API. So here, this is a photo sharing API. Basically, it allows you to upload photos, delete photos, like them. And we saw that earlier broken object level authorization issue, right, where you can edit an order that you didn't own or you didn't create. So in this example with this photo sharing API, I want to show you all how can you delete a photo that you don't own. So very similar type of authorizations. And the way we're going to do this is we're going to start with the design. So you see the design there on the very left. We're going to lock down the API's definition. So I mentioned that static analysis of the contract, the Swagger. That's what this first design piece is. So basically analyzing the Swagger for any of those security or data flaws. And then we're going to recommend best practices to fix those. And the goal there, what that's going to achieve is locking down the API's definition. So basically, we're going to reduce attack surface of that API. Then we're going to leverage that contract to do automated testing. So security testing on that API just by having the contract, the Swagger definition, and a running API. That's really all we need. So I'll show you guys how we can then test it, uncover those vulnerabilities related to the OWASP API top 10. And then we're going to fix the issue. So this third one here. And this is kind of cool. We're going to actually leverage, if you all have heard of GitHub Copilot, it's like an AI engine. You can leverage that and ask it questions. And we're going to use that to actually try to fix one of these broken authorization issues that we'll end up finding here. And then lastly, we're going to deploy the code. So we'll push up the code to source control to GitHub, and they're going to see all the automation now that's going to kick off. It's going to run the same kind of static dynamic checks that we're doing on the API locally and validating. It's going to validate them one more time in the pipeline. So the idea there is, right, if a developer missed something locally, once they commit to source control, the automation kicks off, it will catch anything they may have missed. And by the way, this is an Express app written in Node.js. So if you all want to pull down the code base, if you're curious, this is a pretty cool repo. It has a bunch of OWASP API top 10 vulnerabilities and a lot of things you can kind of learn from this one here. So what I'll do is I'm going to flip over to my workstation, which is my developer environment. So I'm actually using VS Code. So you see here I have open a Swagger definition. I have a source control repository here on the left, and there's my Swagger. So I mentioned, in 42Crunch, we have a plugin, right? So developers can download this plugin directly in their developer environment. So VS Code, IntelliJ, Eclipse. You can just search for it here on the left-hand side in extensions. So I can basically just type in 42Crunch. I'll find the plugin, and then you can download it. So the cool thing is you can actually use this plugin for free. It does have some usage limits, but if you just want to get started today and you want to try it out, you can start doing the static and dynamic analysis immediately on your APIs. So again, I have a Swagger definition open. I have a running API, so I can actually do this. So I have this API running on localhost, and basically I can just double check. You can see it's up and running right here. And so I have an API running. I have the Swagger definition. Now, what I want to do is first analyze the design. So we look at this first step, design here, locking down that API's definition. So we can do this very quickly. Once you download that plugin I mentioned, you'll see in the top right, it says security audit. You can click this little purple button here, and this is going to analyze that Swagger definition. So again, this is looking for any data issues, data validation problems, any security issues, if you haven't defined proper authentication, things like that. And the cool thing is there's even guidance for developers directly from security. So when you think of DevSecOps, this tool really provides that sort of interface. So if you look at here, security quality gates, this is the security's communication to the developers to help them understand what, if any, issues are with this file. So does this Swagger have any blocking issues that security has deemed a problem? So in this case, security has emphasized that input validation is very important. And you can see we have a forbidden issue in this report. Now, if you just look at the score, right, 92 out of 100, it's scoring pretty high. Like this is a very good overall definition. But in this little security quality gates note, we've noticed that there is a blocking issue. And if we click on this issue, we can actually see what line number it's on in the file. So I can click on the line number, and then it'll take me to that line in the file. So then I can quickly see, okay, this is a delete picture operation. So again, this is a photo sharing API, can upload pictures, can delete pictures. Now, so what's the issue? Well, there is a parameter in the path here. It's an ID, and we can probably decipher it's a UUID, a unique ID, so alphanumeric character. And here it's just defined as a string in the input in the path. So really the issue here is it's sort of left open-ended. So what I can do is I can run the audit just on this operation again, so I can get a clear picture. Does this operation have any other issues that I should be aware of? So this is going to again analyze just that operation. And again, it's going to find that, okay, we do have a missing pattern defined for this string. We also have a missing max length. So what would you do next? Well, you can definitely read more about these issues. So by expanding this, and I can understand, if you're unfamiliar with this issue, with why you need to define a pattern for a UUID or a path parameter, this will sort of explain that. So this is a lot of guidance in learning for developers. And me personally, I've learned from this as well. And basically, right, the idea is if you can define a strict pattern for, in this case, what is a UUID, and you define that in your API definition, and then your API implementation actually respects that pattern, meaning it validates the pattern on the request, then you're effectively securing that operation and that parameter from any sorts of attacks, from things like bad injections, like SQL injection, command injection. You're reducing the surface area where an attacker can say, hey, I want to go ahead and put a SQL command in for that UUID, right? So by validating the pattern in the design and then testing against that, which I'll show you guys here in a second, then you'll get the coverage of that. So this is really the idea is we want to address these issues in the design. And so there's a couple easy ways you can do it. You can just hover over that issue, the schema, do a quick fix. You can see, again, I have a missing pattern, a missing maximum length. And so you can simply inject those properties. So you can see here I'm adding in the pattern and I'm adding in the max length. So this is a quick way to do it. And then you can fill in the values with the appropriate values if necessary. Now, if you want to take this a step further, you can simply check and see, hey, do I have these formats in 42Crunch? So I just clicked on this little data dictionaries guy here. And this is going to open up this new window. And this window is going to show me all the formats that we have in 42Crunch. And I can actually see I do indeed have this UUID format. And it's fully defined. It's got an example. It's got a pattern, min, max length. So I can just leverage this. And the cool thing here is we really just use the existing Swagger keyword. So I can actually delete those pattern max length that I just added. And instead, I'll just put this format keyword. And I'm basically going to tell the Swagger that this is a UUID format. So you might already have these formats in your Swaggers today. 42Crunch just checks it. So if I just click the audit one more time, it's now going to notice there's a format, but there's no data dictionary properties in the document. So it's going to say, hey, would you like to update this document? So when I click update, it's going to inject all that data from the dictionary. So example, pattern, min, max length, and effectively enhancing my documentation, right? So now what we can see from the static report is the global score is higher, and we've cleared all those security issues. So now I know immediately from this static analysis of this file that I, as the developer, am meeting my security team's requirements in terms of my design. My design is meeting those, and there's no blocking issues. So this is great. So from here, I know I'm good to go on my design, and now I can use this design to dynamically test my API implementation and ensure I don't have any of these vulnerabilities. So flipping back to this slide here, what we just did was just the design. So we locked down the design, reduced the surface area by fully defining request responses using that audit report as the guidance for remediation. The next step here is now to test. So testing the resilience and the behavior of that API. We can do this now, again, using that 42Crunch plugin, but instead of doing a static analysis of this Swagger, we're going to click on this little scan icon underneath the operation. You can click on this on any operation. It opens up this scan UI, and now you can actually see all the different operations of this API. You can actually test each operation individually. You have these try and scan buttons in the top right. But in my case, because we're doing a delete picture, I created more of a scenario. So you can actually define these custom scenarios where you can say, okay, for example, if I want to successfully delete a picture, I have to make sure a picture actually exists first so I can have an ID to delete. And so that's what you can do is you can set up these business logic scenarios like I've done here for delete picture. And normally it would just try to delete a picture with some ID. But I'm supplying that ID in this previous step, which uploads a picture. So that's the cool thing is I can try this and it'll send a real request at the API, which is running on localhost. Because again, you can see I have the API running on Docker here. So I'll go back here and click try it. And so then you can see it's hitting localhost, sending a request. It's actually uploading this picture. And in the response, it gets back a unique identifier. This is a UUID. This is what we were putting in the pattern for effectively. And then it takes that UUID and it passes it to the delete function in the path. So we can actually successfully get a 200. The picture is deleted and this scenario works. So this is effectively a successful happy path scenario. We can basically test that API and validate, does it work? Does it give us back a 200? This is one of the things that the scan does first, because if you think about it, we're not looking at the source code here. The way this analysis is happening is through the Swagger document, taking the Swagger and the API endpoint and sending security tests at the endpoint. So because of that, we need to first validate that whatever's been implemented and deployed on the API side is matching the OpenAPI specification or the contract. And so that's what this validates. So again, now I can run this scan here. So I click this little scan button. This is going to run the scan. And so now it's going to send all those security tests that I mentioned, including validating that the happy path works as the very first step. Validate the API works. You can see here, happy path testing results. We got back at 200. So we validated when sending good data to the API, we get back good data. And after that validation, you can see all the security tests are going to be run up here. So if I just look at the most critical high test in the top right here, you can see there's 3. So here we see a few. We see some undefined verbs with and without authentication. But really what we see here is the highest, most critical issue is a broken object access level authorization. So this is on the delete picture operation. You can actually see the delete picture returned a 200 response. We expected, of course, a 401, a 403, a 404, some sort of authorization issue, mainly 401 and 403. And you can see the attack. So in this sample request here, essentially what's happening is it's deleting this picture, this UUID right here, and it's attempting to delete it with this user, user 3. So this picture was created by another user, ultimately. And so this user is able to delete user A's picture, and you can see it gets a success. So this is something that we've discovered a vulnerability. So we've tested, right? And we've found a vulnerability, which is a broken object level authorization. It allows a user to delete another user's picture. And we validated that because of the 200 response that we're getting from the API. So we want to fix this, right? And if you look at the JSON pointer, I can start to kind of get a hint. You know, it's the delete operation, of course. So you can click on this pointer. It takes me back to the Swagger, right? And here is going to give me more information on that API. So I can make changes to the Swagger here if necessary. But in this case, it looks like we're going to need a code change. And the reason is because the code is not behaving appropriately. It's allowing users to delete other users' pictures. So how are we going to basically go about this? So again, we finished that test. And what we want to do now is we want to fix. So we can try to fix the code ourselves, but what we really want to do is leverage GitHub Copilot. And so I actually have this Copilot chat right down here. So I can ask it questions, kind of like ChatGPT, and it'll give me answers. So it's pretty cool. It's conversational. And I also have, since this is a Node.js app, in the app folder here, I got a server.js. So this is actually where all my functions are defined. So if I look in here for API delete, I know this is my delete function right here. And the cool thing too is, there's a comment right here. It's basically helping us out, right? It's telling us that there is a BOLA issue on this operation. So what does it look like is happening here? This is a delete picture. So basically you're passing your token, you're passing a picture ID, and this is going to delete that picture. Looking at this code, it looks like there's no checks whatsoever. It literally just grabs the picture based on the ID, and then it will try to delete it if it exists. That's pretty much it here. So what we want to do is add that authorization check, right, to this flow. So let's ask Copilot. I can ask Copilot something like, let's think about this for a second. If you remember from that editing an order, right, you had an order ID and you had a user ID associated with that as well. So since this has to do with pictures, there is a picture ID, right? But there's also a creator ID, a user that created this picture. So we should be able to fetch that creator ID and compare it to the user making this request and ensure that they're the same user. And so that's kind of the validation we want to add in. So one thing I could ask Copilot would be, how can I check the picture creator ID before deleting it? And so basically, how can I check that? And a lot of the times the Copilot, which is pretty cool, it'll actually notice, which function I'm talking about, right? A lot of times it'll reference, you can see it here, it's referencing that picture.id. So I know we're in the same function. It knows what function I'm referring to, and it's giving me a whole bunch of cool data. So if you look at this real quick, this is like basically everything you would need to do in order to fix this issue, right? We're fetching the picture. We need to check the creator ID. It makes some assumptions that the creator ID is, creator ID. So we can correct those if necessary. And then it's going to delete it if that user is authorized. So that's really what this entire code block is doing. If you kind of compare it to this guy right here, this is the old code, and the left-hand side is the new code. So what we ultimately can do is just copy that entire block over into the editor. So I just clicked on this little button right here. And so I'm taking that entire code that Copilot suggested, but obviously you want to spot check these things, right? You want to ensure that the assumptions that were made by Copilot were correct, because if you scroll down at the bottom here, it's also going to tell you, right? It's assuming this is how it can get the user ID and the creator ID. If these assumptions are wrong, you obviously want to correct those. So if we just take a quick look, it looks pretty good. We're pulling the pictures object from the database as we usually do, checking if the picture exists. But right here, you see this assumption? It thinks the creator ID is just creator ID. Unfortunately, it's not. It's actually an underscore ID, which is totally fine. It's just making an assumption. Same thing with the requester ID. So this is the user that's requesting to delete the picture. This one actually comes from user profile. Yep. And then it would be the underscore ID. So just correcting a couple assumptions, we can set this to a 403 or 401, it doesn't really matter. So this is really the code fix, right? So this is what was added by Copilot. This is that check. And then this was the original code down here, which just deletes. So this, looking at the code, looks pretty good. What we can do next is we can go ahead and build this app. So I'll run this quick build script. It brings down, it's basically 2 Docker containers that are spun up for the API. So it brings down those containers, and then it's going to build the app, spin it back up. Usually takes a few seconds. And then once this finishes, so what we've just done there is we've added in the fix. Now, before we deploy, I just want to validate, did the fix work? And even if we didn't validate if it worked locally, you still would validate it in the pipeline. But obviously, we want to validate our work. So going back into that scan interface, I can, again, I'm in the same guy here, this delete picture. So same operation. I can click on try it again. And you see, we didn't break anything, thankfully, right? So we still get a 200. The happy path works. And so now we'll click scan one more time. Now, when this scan runs, because we put in that code fix, the logic should handle that authorization check. And we should not get a 200 response. In fact, we should get a 401 because that's how we programmed it in the API. So again, looking at this guy, let's close this console. So now we only have 2 critical high. Notice last time it was 3. So we don't see the broken object level authorization issue here anymore. So let's go back to the summary. If you look at the total tests executed, 21 tests, we see various tests here. I'll scroll down a little bit. And here we can see the broken object level authorization test. However, now it's passed. So if we expand that, we see, okay, so if you recall before, we were getting a 200 when this test was ran, but now we get a 401. So it looks like the code fix was good. It fixed it. And you can see here, right, based on what data you have in the Swagger, these are all the different tests or some of those different tests that you're going to see, right? Like the mid-length checks, the regular expression checks, the max length checks. You're going to be able to see, for every single one of these requests, what did the scan send? How was the pattern violated? What was the response from the API? And so really, this is where the documentation really comes into play, because all of these different tests that you're seeing, these are all leveraged from your documentation automatically. So no need to write custom tests. For things like authorization tests, you just simply, you create a test and you tag an API with it. So very simple to kind of set up these types of things. And then ultimately, right, once you have the code, the code ready to go, you can actually push it up. So you can see here in my source control, these are kind of the different changes I made. So here's my pixie.json. This is the Swagger definition. You can see the changes I made. I just put in that format with the example pattern, min-max length. And then what did I do for the server.js? Well, it was really the GitHub Copilot did it for me pretty much, right? So it was the code fix right here. So I'm just going to commit those, push them up to source control. We'll also push that one up, and we'll just say delete picture fixes. So now when you kick this guy up, now it's going to kick off all the different automation in GitHub Actions. So remember we did design, test. We were doing this stuff locally. This is now going to get run when we deploy as well in CI/CD automatically. So you can see I just kicked that guy up. If we go back to here, GitHub Actions, I have it installed in my developer environment as well, so I can see it right here. If I refresh this pipeline, I should see a new one coming up. So this new workflow right here is going to now validate that latest code change that I pushed and ensure that it also doesn't back in GitHub Actions. So you can see the reporting in the UI here, and you can also click on this little link. I think it's going to open it somewhere else. Here we go. So you can actually see the action running. So here's that latest commit. And this action actually has 2 parts. So basically, it's this main workflow, and it runs an audit and it runs a scan. So if I go back to kind of the workflow folder here, I can kind of show you guys. Main workflow. So this is really what the GitHub action is. It's just this Docker image, essentially. that runs in GitHub Actions. So you just pull down the 42Crunch image and you give it a token and you're good to go. And this will also discover any APIs in your repos. So like if you notice in this repo, I have this OAS files folder. And within this folder, I have the Swagger files, the OAS. So it will actually discover any files that you have in source control and automatically analyze and import those into the backend for further analysis. And so you can kind of see it. It should be finishing up here too. And then the cool thing is all the reporting. So all the reporting from this, right? We saw the reporting in the developer environment, but it also can get uploaded to code scanning. So if you've heard of GitHub Advanced Security, you got this little security tab right here in the top. You can click on that. And under the code scanning section, you're going to be able to see for that API, when I mentioned we're running the static dynamic checks in the pipeline, these are the results right here. So this is going to show you now, like if I filter on static checks, where are all the places in my Swagger where I still haven't defined a pattern? In this case, it looks like, only in the response. But again, you can validate and double check, have those requirements been met? And you see all the reporting here. I can also click on these. It'll show you all that same, verbose information that you see in the developer environment, so you can understand why these are issues. And then if you scroll all the way down, you can see the very initial SHA on the commit of when this issue was introduced. So you can kind of maintain and track the life cycle of that issue over time as well. And it looks like it finished. So again, those checks kick off in CI/CD, validates everything. If there was a validation issues, you can also block in CI/CD, so you have full control, right? It's really security sets the policy, and developers can kind of consume that and then follow it. So back here, we just deployed, and we fixed the issue. So that's kind of the end-to-end, solution. That's kind of, again, what I described in the beginning. If we go back to that initial software development lifecycle slide, this is how we're going to fit into that process. And it all comes together with those security quality gates, where security can define those policies and customize those. So, Hars, did you want to take over on the Defender for Cloud side of things?
Yeah, definitely. Thanks for that, Hisham, and great demo there. So yeah, now we'll talk a little bit more about how this kind of all integrates together with some of the Microsoft product suites that we have here as well. So we'll be walking through next how 42Crunch integrates with GitHub Advanced Security. You saw kind of a sneak peek with that with the latter half of Hisham's demo. And then we'll also talk about how this integrates with Microsoft Defender for Cloud as well. That's basically empowering security teams to now have broader visibility and governance to make sure that nobody's pushing any insecure code into production, for example. So with that, I'll actually go and share my screen now to walk through how this kind of looks kind of end to end with both the GitHub Advanced Security side and Defender for Cloud piece. So you should be able to see my screen now. Here we're in GitHub in this case. So very similar to Hisham's demo here, we have just a sample workflow in this case. So if I go into this workflow, you'll see that we have the 42Crunch audit step in this case. So we're not running that dynamic piece, but we are running the audit step in this case. And you can see that this workflow runs any single time I make a new push to the main branch in this case. So we kicked this off just earlier a couple days ago, and you can see that this flow ran. And it actually ran the 42Crunch workflow, and you can see that it uploaded those results to the code scanning tab as well. It had some issues in this case. It found that one of the specs in this repository only had a score of 5, and the other one had a score of 82. So as Hisham showed kind of earlier, this is really the goal for the developer workflow. As a developer, you can go to the code scanning tab and you can actually see all the different flaws in this case as well. So not only can you see them in the IDE environment, but if you missed anything, you can actually double check and catch it within your CI/CD pipeline as well. And this is really great for security teams to really enforce that developers are actually running these API security tools within your various repos within your organization as well. So in this case, you can enforce that every CI/CD pipeline should run the 42Crunch scan in this case, and you can see those results come back. So as Hisham mentioned, this result will show all the details that you need as a developer to actually go through and understand what went wrong, as well as how to go and fix it as well. So that's really the goal of this part of the integration. And again, this showcases how these results actually showcase within GitHub Advanced Security. So that's great. In addition to this, we can also see these results actually show up within Defender for Cloud as well. So this is something that many security teams are already using for kind of a comprehensive coverage of their cloud security across their runtime resources and their development time resources as well. So let's go and kind of see a demo of how this works all together. So in this case, within Defender for Cloud, I'm going to go to the Recommendations tab here, and we'll actually have a new recommendation here within Defender for Cloud for API security testing. So let me just go ahead and search for that. And in this case, you can see that we have all of these different recommendations showing up. So in this case, we have many different repositories that we've onboarded to Defender for Cloud across my entire organization. And you can see that all of these have various API security testing findings that need to be resolved in this case. So let's go back to that same repository that we were at for API security in this case. So I'll click into this one here. And you can see that now as a security team, I will get that same visibility within Defender for Cloud. So I might not have access to all of these repositories, for example, but I will have access to Defender for Cloud. I already use this for my runtime resource health. Now I can see the health of API security testing within the same platform as well. So in this case, you can see that this is an API security repo in this case, and you can see those same exact security checks show up here as well. And if I were to click into one of these, it will actually let you have reference links back to that specific repository. So in this case, for example, you can see this came from that 42Crunch REST API static security testing scan. And I can actually see that for this particular result in this case, I can go and see it within GitHub as well. So we'll load up that same exact result that we just showcased earlier. So that's, again, really the goal here, is that for security teams, now you can have kind of unified visibility to make sure that nobody's pushing any insecure code into your runtime resources in this case. There's also, of course, actions here as well. So for example, if you want to automate any of this piece, so for example, you can also set up workflow automations to trigger logic apps in this case. This could be for setting up some sort of Jira ticket or ADO ticket to actually assign owners for this case, or any other sort of governance that you might have for the application development teams that need to go and fix this issue in this case as well. And then one last piece I want to walk through here is that this also integrates with some of our deeper cloud security posture management feature sets that we have within Defender for Cloud as well, including the Cloud Security Explorer. So really the goal of this screen here is essentially security teams have to deal with a lot, right? You might have hundreds or thousands of security recommendations and vulnerabilities across your entire organization. So it's really important to prioritize in that case. So this makes it super easy to have different prioritizations that you would like to do. In this case, let's walk through an example of how this works. So in this case, let's say, for example, I'm really just interested in finding out what API security testing vulnerabilities I have within my organization. But to prioritize, I'm only first interested in the ones that are public repositories. So ones that are not private, in this case, are publicly accessible. So here within a few clicks, we'll actually see how easy it is to actually query for that within my organization. So here, I'll go to DevOps here. I'll search for code repositories. And in this case, I can add in this recommendation that we just walked through. So we'll go to, we'll search by title in this case, and we'll say, just show me the results for repositories that have API security testing findings that need to be resolved. And let's only show that where it's unhealthy in this case. So we know that there are actual findings that were pushed to runtime that are in this case unhealthy. So there's that part. And let's say, for example, I want to filter this even further. So as I mentioned, I'm only interested just to prioritize, only interested in repositories that allow for public access in this case. So these are public repositories. So now I can just quickly hit search here. And you'll see that the same exact repository came back here as well. So in this case, you can see API security show up. And you can see that same recommendation, GitHub repository should have API security testing findings resolved. Again, I can see all the details for this repository as well. And if I want any more details on the repository or the recommendation, I can click here and go back to that same exact view that we just saw as well. So again, that's really the integration that we have in place now with 42Crunch, and showing those results within Defender for Cloud to enable that unified visibility and governance for security teams. So with that, I'll hand it back to Hisham to go back to the presentation. We have a few more slides just to kind of wrap up, and then we'll open it up for any Q&A.
Cool. So this one right here, Hars?
Yeah, you can go to the next slide here, or two more here. Great. So this is just one last piece to wrap up the part on Defender for Cloud. So as I mentioned, Defender for Cloud is not just focused on developer security. It's really focused on full lifecycle cloud native application protection across all of your cloud resources in this case. So we do have another plan available within Defender for Cloud specifically for runtime protection of API security. So this includes runtime threat protections, as well as other posture-related scenarios that you can have within your runtime resources. So that's a plan available within Defender for Cloud. And the idea here is you can now enable that plan for runtime protection of any APIs that you have published within Azure API Management, alongside this integration with API security testing, all within kind of one unified platform. And if you're interested in learning more, please do feel free to visit the Defender for Cloud page, and we have a few other links here later on that can go through more detail for that as well.
Last one here. So everything you just saw, you can do for free by downloading our plugin, your favorite IDE, VS Code, IntelliJ Eclipse. It does have usage limits, but again, it's free to try it out. And your favorite CI/CD, right? GitHub Actions, GitLab, etc. And then APIsecurity.io. It's the industry-leading newsletter for all topics related to API security, breaches, trends, current events, things like that.
Great. So with that, we can open it up for any questions that anyone has in the chat. Yep, somebody asked if we can share the repo. We'll share all those details as well here later on in the chat. And I think you were able to see it in the last slide as well. That should have some references to that repo as well. Great. If there's no other questions, thank you all for your time today. And again, we walked through the next steps here for if you want to learn more and if you're interested in kind of onboarding, you can go and check out the resources that we had there. But yeah, thanks again, everyone, for the time today.
Thanks so much, everybody, for joining us. Thanks to our presenters for another fabulous session. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23009. We'll see you for the next one.